Hi everyone, today's lesson is for Geometry Advanced students who are going to be taking their Chapter 3 unit test this week. So let's get started on our review. Just to get started, we have a warm-up. Find the sum of the interior and the sum of the exterior angles of a 20-sided polygon. So the sum of the exterior angles, no matter what shape it is, I like to draw a polygon like this where I have any kind, it's like an n-sided polygon. So you have like the outside of that, and then this being my exterior angle here. The sum of all of my exterior angles, this one right here, is always going to be 360. So the sum of the exterior angles is 360 degrees. This being a 20-sided polygon is not going to affect that. That is always going to be 360 degrees. For my sum. So my sum of my exterior angles is always going to be equal to 360 degrees, no matter what shape I have. But the interior angles is going to be different. So basically, we have a 20-sided shape. So we are going to use the formula to find the sum of the interior angles. We're going to use this formula, 180 times the quantity n minus 2. So that's going to be 180 times 20 minus 2, which is 18. So we have 180 times 18. So 180 times 18, I'm going to use my calculator for that. So for this one right here, 180 times 18 is going to be 3,240. So the sum of my interior angles of my 20-sided polygon will be 3,240. Okay, there you go. Okay, just a note, had I wanted to find each individual exterior angle, all I would have had to do was take the sum, which is 360, and divide that by 20. And so canceling that, that would have given me one exterior angle of 18 degrees if I wanted to know just one exterior angle. Okay. The next question says, find the measure of one angle of an equiangular heptagon. Now, a heptagon is a 7-sided shape. So I'm going to use my generic polygon here, okay? I know it's 7-sided because that's a heptagon, it has 7 sides. And so it's equiangular, meaning every angle is exactly the same. And we could have just said, instead of saying equiangular, I could have just said regular. That would have also worked. If I were to take 360 degrees and I were going to divide that by 7, that would be 360 divided by 7 is going to give me 51.42 or 43. And that would have given me each exterior angle. And then what I would have had to do was subtract that from 180 and said, well, 180 minus that value, which is 51.43, would give me 128. So one interior angle, or one angle, and they didn't say one interior, so I'm going to assume they're asking for the interior angle, is approximately 128.57 degrees. Okay. An alternate way of doing that, I also could have used my formula, which is 180 times 7 minus 2, and divide that also by 7. So let's see if we get the same approximate number. 180 times 7 minus 2 is 5, and I get 900. 900 divided by 7 is approximately 128.57. So I do get the same thing. I thought I would get like a different approximation, but I get exactly the same. Next question. Suppose a polygon has interior angles whose measures add up to be 11,000. So that's like all inside is 11,000. how many sides would that polygon have? So what I'm going to do is I'm going to use this formula that says 180. That's the sum of my interior angles, which is n minus 2. That's the sum of the interior. Suppose a polygon, how many sides? So I just want to know what n is. So I'm going to divide that by, or actually that's my sum is equal to 11,000. So I don't need to divide this right here. What I'm going to do is actually divide by 180 because I've got the sum is equal to the sum here. So I'm going to divide by 180 on both sides, okay? And let's see, I think that's 61. 1100 divided by 18 is about 61. It's not exact. So these are going to cancel. You get n minus 2 is approximately 61.1. I'm going to add 2 to both sides. So n is about 63. It's about 63 sides. So my polygon has about 63 sides. It's not exact. It's about. My next question says, the measure of an angle is 5x plus 14. The measure of the complement is 3x minus 20. Find the value of x. So basically what they're saying is I have two complementary angles. We all know complementary angles add up to be 90 degrees. So one of my angles is 5x plus 14. The complement is going to be 3x minus 20. And so what I need to do is I'm going to go 5x plus 14 plus 3x minus 20 is equal to 90. I'm going to get 8x or minus 14 minus 20 is negative 6 is equal to 90. And so for this problem right here, so far I've got 8x equals 96. So 8x is equal to 96. Divide by 8, I'm going to get x is equal to 12. Now, I found the value of x. Taking the test, I would actually also ask you for each individual angle besides that. So while they only asked me for x on this problem, I would recommend that you also know that you would need to plug these values in to find the angle. So I would say 3 times 12 would be 36, and 36 minus 20 is going to give me this angle right here is 16. And then I could just subtract from 90 and make that 74 degrees. But to check, I would say 5 times 12, which is 60, plus 14 is going to give me 74. So my two angles inside would also be 74 and 16. The next question right here is asking me, for this one is saying the measure of angle 1 is 105, okay? Find the measure of angle 5, which is here. So we know that 1 is 105 here. Find the measure of angle 5. Angle 5 would also be 105 because that is corresponding angles. Angle 7 would be 75 because that would be 180 because this length here is 180 minus 105. So that would be 75 degrees right there. So then I'm going to erase this because each one of these questions would be independent of each other. Angle 2 is 70 degrees. Okay, so we know that's 70. That's alternate interior angles. We know that's 110, 110, okay? They also said that angle 8 is 6x minus 2. So this is 6x minus 2. Well, if we know that angle 7 is 70, right? Because of this is 70, that's 70. We also know that this angle here is 110. We can set those equal to each other, and so we would say 6x minus 2 is equal to 10. I do not think that that is a, let's see, 112 divided by 6. Yeah, that doesn't come out evenly, but that's okay. That's about 18.7, okay? So about 18.7. So that's solved for x, we just did. That's this value right here. Just a note, I also could have said, well, hey, these are supplementary, and, you know, done that as well. So that this is 6x minus 2, see 6x minus 2. I mean, I feel like I did a shortcut in saying that that's just equal to 110, but I could have also said that 70 plus 6x minus 2 equals 180, and then also solved it that way. Lastly, for this problem, I'm going to solve for y. So I'm going to erase my information up here. Again, start over. It says that angle 3 is 8x minus 40. It says that angle 8 is 2x, I'm saying x, but these are actually y. The measure of angle, that's 8y minus 40, and this is 2y plus 20. Angle 3 and angle 8 are corresponding angles, so they're congruent. So all we have to do is set those equal to each other. So 8y minus 40 is equal to 2y plus 20. Subtract 2y, I get 6y. Add 40, I get 60. So then I get y is equal to 10. And so that's the angle. Remember, just to note, if you wanted to find the actual angle value, you would go 2 times 10, which is 20. 20 plus 20 is 40. So we know that angle 8 is 40. So angle 3 is also 40. All right. Next question says, the measure of one interior angle for this problem is equal to 144. How many sides does the polygon have? So if I know that, I'm going to make my fake polygon here. There it is. And there's my exterior angle. It says the measure of one interior angle is 144 degrees. So that's what that is equal to right there. Okay. How many sides did the polygon have? So I just want you to know there's a couple of different ways to do this. There's so many ways to do this. One way is to take 180 and subtract 144. And therefore, this being a line, that's going to be 36 degrees. Okay. And if I know that one exterior angle is 360 degrees, I can divide that by 36, okay? And I'm going to get 10 sides, all right? So that's one way of doing it. I love doing it this way with my exterior angle because I know that that's like a fixed value. You know that the sum of your exterior angles for any shape is always going to be 360 degrees. So this right here is pretty straightforward. The other way that I would suggest finding this, because you know one interior angle, now remember, this is the sum of all the interior angles. So 180 times n minus 2, okay? That's the sum. But if I want 1, I would have to divide that value by n. So that's one exterior. So this formula right here, that right there is one interior angle. Okay, that's what one angle is. If I wanted one exterior angle, I'd go 360 divided by how many sides, right? Okay. So one interior angle is equal to 144. So the other way that I would do this, right, because they gave me that this is 144, is I would cross multiply and I would say, well, 180 times n minus 2 is equal to 144 times n. Then I would distribute. I would go 180 times n minus 180 times negative 2, which is 360, equals 144n. I would get my n's on the same side, so then I would subtract 144n, and I would have 36n is equal to 360 degrees. I would divide by 36. I get n equals 10. Sorry about that. If I divide it by 36 on both sides here, okay, I'm going to get n equal to 10. So I know that my sides, I have 10 sides. Now, this is sort of, I've already answered this question here, one exterior angle. So one exterior angle has a measure of 36 degrees. We already knew that from just drawing this like fake polygon. So I always draw one of these little polygons, and because I feel like this is definitely going to help me in the long run, which obviously it did. The next question says, find the value of x that makes these two values, or j, parallel to k. If j and k are parallel, then these two angles in here, which are alternate interior angles, would be congruent. So all I would do is I'd say 3x plus 10 is equal to 5x minus 10. Subtract 3x, I get 2x equals 20. I get x equals 10. Find the value of x, and I'm done. I found x. If x is 10, therefore j and k are parallel. Same thing with this. These would be parallel if the same side interior angles were supplementary. So if I went 6x plus 5x plus 15 and set that equal to 180 degrees, they would be that would make these supplementary, which would then, if they're supplementary angles, that would make them the two lines parallel. So we have 11x plus 15 is equal to 180. For this problem right here, I'm going to subtract 15. Oops. Okay, I'm going to subtract 15. And then let's see what we get here. 11x is equal to, we've got 180 minus 15, which is 165. And then I'm going to divide by 11. And I get, let's see, x equal to 15. Okay, so we found x. And if x is 15 and I plug 15 in here, both of these angles then would be supplementary, which would then make j parallel to k. This is like a mini quest. So this is like a practice test. So on this week, you're going to be taking a quest. So this is a mini quest. So let's see how you actually do. So here we go. A regular polygon has 18 sides. So we have 18 sides. Find the measure of each interior angle. So again, way number one is to use the formula 180 times n minus 2 divided by n. So n being 18. 18 minus 2 divided by n, which is 18. So I've got 18 minus 2 is 16. And 18 will divide into this 18 10 times, and 10 times 16 is 160 degrees for each angle. That being said, I just want to reiterate that I personally enjoy drawing my little fake polygon. And if something has 18 sides, I know that one exterior angle is going to be 360 divided by 18. And 18 divides into 360 to here 20 times. That would leave me with one exterior angle of 20 degrees. And then if I subtract that from 180, I get one interior angle of 160 degrees. So I just want you to be aware that, again, there's other ways to do these problems. This is the way I prefer, but you can also use the formula. Either way is okay. A regular polygon, again, has 24 sides. Find the measure of an exterior angle. So for me, this one is just sort of a no-brainer. 24 sides. It has 24 sides. I'm looking for an exterior angle. So I'm going to go 360 divided by 24. I don't know what that is. Let's see here. 360 is probably 15 or something like that. Let's see here. 24 goes in there once. Subtract 24 to, 120. And 24 goes into that 5 times. So we have 15. So one exterior angle is 15 degrees, and that's it. Each has a measure of 150 degrees. Okay, so for me, what I'm doing is I'm saying, well, I know one exterior angle, therefore, is 30 degrees. Okay, so if one exterior angle is 30 degrees, I'm going to take the sum of my exterior angles and divide it by the measure I have here, and I get 12. And so that means that I have 12 sides. Now, just a note, of course, the only way that I could have done that, I could have said each interior angle. So I could have used the interior angle formula, which says 180 times n minus 2 divided by n is equal to one interior angle. So they told me that one interior angle is 150 degrees. So I can solve this by cross multiplying, and I would distribute at the same time. So I get 180n minus 360 is equal to 150n. I'm going to subtract 150, I get 30n. I'm going to add 360, I get equal to 360. I'm going to divide both sides by 30, and then I get n is equal to 12 again. So again, I'm just saying there's different ways that you can do this. Pick the way that works the best for you, and that's the way what you should stick with. For me, I love this exterior angle formula because I know that the sum of all my exterior angles, regardless of the shape, is always going to be 360 degrees. And then I just divide by either the angle or the number of sides, and I get either. Let's keep going. The sum of the measures of the interior angles of a polygon is the same as the sum of the measures of the exterior angles. So how many sides does it have? So, I mean, think about that, people. You're thinking, I'm thinking 4 right off the bat, 360 degrees, but there is a way to do this formula-wise, okay? The sum of the measures of the interior angles. So that would be this formula, 180 times n minus 2, because that's the sum of the measures of the interior angle. So that's the formula for just that part right there. That is the same as, that's equal, the sum of the measures of the exterior angles, which is 360. Distribute, we get 180n minus 360. Is that right? Equals 360 degrees. I'm going to, what am I going to do? Add 360 and then divide by, oh, actually, you know what I'm going to do? That's just a bigger number. I guess I get 720, I'm not going to do that. What I'm going to do is be smart, and I'm going to divide by 180 right off the bat. And then I'm going to cancel these out, and I'm going to get n minus 2 is equal to 2. And I get n equals 4. So that means that I have 4 sides. But you knew that, right? You knew that. AC is a diagonal of a regular pentagon. So I'm going to draw my pentagon. A pentagon has 5 sides. 2, 3, 4, 5. So let's go A here, B, C, D, and E. AC is a diagonal. Okay, so let's draw that in. AC. Okay. What is the measure of ACD? So, they want that angle right there. Well, that's kind of cool. Let's figure that out. What we know is diagonals are congruent. Would you agree with that? Okay. I know that, let's see here. We know that the sum of the angles of a pentagon, let's see here, is 180 times 5 minus 2, because n being 5 sides, right? 5 minus 2 is 3, and 180 times 3 is 0 here, 4 to 540 degrees. And if I were to take 540 degrees and I was to divide that by 5, each one of my angles would be 108 degrees, right? Except for this weird angle, because that's cut. But this would be 108, right? Okay. So the way I'm going to do this problem, I know that there's other ways to do this. Like you can make this into a isosceles triangle, etc. I'm not going to do that. What I'm going to do is, using this diagonal AC, is I'm going to make this into an isosceles triangle. And I know that if the sum of the angles of a triangle add up to be 180 degrees, and if the sum of the angles add up to be 180 degrees, and I were to take 180 and subtract 108, what does that leave me with? 72, right? So let's see here. 180 minus 108 gives me 72 degrees. So that means that this angle and this angle would add up to be 72 degrees, which would mean then, because this is an isosceles triangle, that both of these angles here and here would have to be the same measure. So if I divide that by 2, I do get 36 degrees for one of the angles, for both of these angles. So ACD, ACD. So, ACD. So this angle right here is 36. That's not what they want. So they want the other angle. So I know that this angle right here is 36. Let me erase that so I can draw that in there. Okay, so they know this little angle in here is 36. So therefore, this angle here being 108, I now just have to subtract 108. I just have to subtract 108 minus 36 degrees. And what is that? 72. Cool. So that means this angle, ACD, which is the angle they want right there, that's going to be 72 degrees. Cool. All right. That's a neat problem. I love that problem. Okay. The next question says A, B, C, and D are coplanar points. Okay. That means they're all in the same plane. In the same plane, meaning like that, right? We know that AB is parallel. So let's go like this. AB. So here's AB. Parallel to CD. I also know that AB is perpendicular to AC. Okay, all right. So that means that there's a line going straight down like that. Perpendicular means right angle. And now I can't see my little A here, so I'm going to move A over a little bit. Okay, so now it says ACD. Well, if that's perpendicular, if these are parallel, right, and this is perpendicular to that, it also is perpendicular to that. Remember, that's one of our theorems. Therefore, they want to know, they say that ACD is 2x plus 8. Find x. Well, that's 90. So we're going to go 2x plus 8 is equal to 90 degrees. Subtract 8. If I subtract 8, I get, 82? So I get 2x is equal to 82, and then x is equal to, divide by 2, 41. All right, cool. Almost finished. Almost finished with the review. If two parallel lines are cut by a transversal, then the alternate interior angles are always congruent. Okay? All right. Next, when two parallel lines are cut by a transversal, 4 pairs of angles are formed, 2 on the right, so 2 on the left, because it's like this: corresponding top, corresponding bottom, corresponding top, corresponding bottom. That's 4 pairs. Lines that do not intersect are either parallel or skewed. Parallel to CD, and CD is parallel to EF, then AB, by the transitive property, AB is parallel to EF. Okay. The measure of each interior angle of a hexagon is 120 degrees. That's one of those ones I ask you guys to remember, but just in case you forgot, let's just do this. There's my hexagon. SATs like to ask you questions on hexagon, so it's really in your best interest to remember that the sum of the angles of a hexagon is 720. 180 times 6 minus 2, so that's 4. 180 times 4, is it 720 or 740? Yeah. 0, 8 times 2, excuse me, 8 times 4 is 32. Oops. Okay, messing myself up here. Is 32, carry the 3, 720. There we go, check. And if we were to divide that by 6, we're going to get 1. Subtract 6, 1, 2, 2, 0, 120. So each angle in a hexagon is 120 degrees. And of course, that is the long way to do it. I just want to show you the shortcut way, which is my favorite way, is just to make a regular little polygon edge. And if it's a hexagon, I know it has 6 sides. So if this is my exterior angle, I'm going to go 360 divided by 6 is 60. So that's 60, which would mean that is a line, which would make that 120 degrees. Way quicker, in my opinion. Anyway, that was the question, 120 degrees. Okay, the next question says, if each exterior angle has a measure of 15, then how many sides does it have? So again, each exterior angle is 15. Now, I could find the interior angles and then use the interior angle formula to do this, but don't need to do that. All I have to do is say 360 divided by 15 degrees, and what is that? 2, 4, 24. I get 24 sides, so 24. Okay, 24. Okay, next question says, given a, oh, we have an Ambler alert. Okay, so we have, next question says, these are parallel, so AB is parallel to, and C is parallel to D. So these are all parallel. Okay, so find the angles that you need to find. What we know for the first problem is that, what do we know? We know that if this were to continue, this would be right here an alternate interior angle, so X would be 70. The sum of the angles in a triangle do add up to be 180. So 70 plus 65, 5 here, 135, right? And if I were to take 180 and subtract 135, I would get 5, 8, 7, 45. That would make this 45. And 70 and 45, right? So this right here would make a straight line. So 70 plus 45 is 115. And if I were to subtract that from 180, 115, I would get 65. So y would equal 65 degrees. Okay? So y equals 65 and x is equal to 70. For this problem here, for number 14, we know that this would be 50 because this is a right angle. And we also know that if these two lines are parallel, then if this is a right angle here, this also is a right angle. So we know that x is equal to 50. We know that z is equal to 40 because that would have to be 40 in order to make a 90-degree angle. We know this angle is 110 because 70 plus 110 makes 180. And what else do we know? This angle here, right here. Well, I mean, there's a couple of things we know. We know that this here and this those are alternate interior. There's a couple ways to do this. I'm just going to do this. 110 plus 40 is 150. Okay, that means this triangle right here is going to add up to be 180 degrees, and these two angles is 150. So that means that y is going to equal to 30. Now that's just one way to do that. I could have also have said this is 70, and so therefore that's 70, and if that's 40, then that's 30. And I think actually that's a little bit quicker. So the definitions, this is one of these times where I think you should pause the screen. Make sure that you know all of these definitions because they will all be on the test. You're expected to know all of these on the test, quest, whatever you want to call it, the exam that you're going to have. All of these values, all of these definitions are on the test. Additionally, all of these postulates and theorems and corollaries are also on the test. You've got corresponding angles, alternate interior, same side interior, perpendicular, transversal, all of the converses. Two lines perpendicular to the same line are also perpendicular. Two lines parallel to the same line are parallel. And of course, auxiliary lines are lines that you can draw in to, any shape so that you can, work something out to solve the problem. So you can draw in any kind of auxiliary line that's available to you. Postulates, theorems, more postulates, theorems, and corollaries. Triangles, angle sum theorem basically says all the angles in a triangle add up to be 180 degrees. We've got each angle of an equiangular or side of an equilateral triangle. Those are all 60 degrees, the angles. There's at most one obtuse angle and one right triangle in a triangle. The two acute angles in a right triangle, of course, are complementary. triangle exterior angle theorem basically means that if I have a triangle and then I have an exterior angle, that exterior angle is equal to the sum of the two remote interior angles, right? The sum of the measures of the interior angles is n minus 2 times 180. One angle would be 180 times n minus 2 divided by n. And then lastly, the sum of the measures of the exterior angles is 360 always. If you want one exterior angle, that was one interior angle. If you want one exterior angle, that's going to be 360 divided by n. So this is from your chapter review worksheet that I'm going to be doing. Just reviewing a couple problems, not all of them, just some. I think enough to help you. We know that our job is to probably find the measures of blank, blank, and blank. I don't remember what it said. There's no value here, but I'm going to just do this for you and see what we get. We know that these are alternate exterior angles. And if that bothers you, that they're way away from each other, you could put them in here. See, that's 2x plus 8, vertical angle theorem. And this is 4x plus 2, right? Those are alternate. Now they're alternate interior angles. You know that 2x plus 8 is going to be equal to 4x plus 2. We get 2x is equal to 6, subtract 2, and x is equal to 3. So then I'm going to plug these values into my equations to get my angles, and I'm going to get 2 times 3, which is 6. 6 plus 8 is 14. So that's 14 degrees. That's 14 degrees. That's 14 degrees. That's, oops, hold on. That's not right. This is 14 degrees, and that is 14 degrees. And just double check 12 plus 2 is 14 degrees. And then now what we would do is we would try to find the other angles. So that's going to be 180 minus 14, which is 166. That's 166. That's 166. And that's 166 degrees. The next question says these are parallel. So if these angles or these lines are parallel, we know that a few things. We know that alternate interior angles are congruent. That would make this a transversal, which would make this equal to this. We know, well, that's not going to actually help us too much right now, but 5y is equal to 2x. That might help a little bit later. What do we know? We know that this is a 30-degree angle right here. We also know that this whole line right here is a line. So I know that 30 plus 5y plus, I don't know what that angle is though yet, plus whatever that empty angle is going to equal to 180, okay? Let's look and see, do we have any alternate interior angles? Do we have anything that we can say that we actually know? We know that this plus this plus this adds up to be 180 degrees. I know that this angle right here and this angle here are vertical angles. And then that means that this angle here is congruent to this angle here, those being alternate interior angles. So let's hold that thought. Now, I know some of you may be thinking, hey, why don't we just say 5y is equal to 90 degrees? We actually don't know that unless they told us, which they did not tell us that in the instructions. But what I do also know is that this equals that. I know that x minus y is equal to 30 degrees, okay? I also know that 5y is equal to 2x. Now, if I were to put those on the same side, you see what I would do is I would say 2x minus 5y and move that to the other side, and now it's 0. So I could say that 2x minus 5y is equal to 0. So we finally have two equations that we can use. Now, it's a system of equations. To solve this system, You're either going to solve this by elimination or substitution. If I were solving this by substitution, I would set x equal to y plus 30. And then I would plug that into right here where it says x. Do I want to do that? I was thinking, though, of multiplying this entire equation by -2. And in doing that, I would get negative 2x plus 2y is equal to negative 60, because you have to take that -2 and multiply it by everything. Now, this is the part where you can do it the way I'm doing this, or you could do it by substitution. That's your choice. We're going to get the same answers. We have 2x minus 5y is equal to 0. I'm going to add these two equations together. And in adding these two equations, those cancel. I get negative 3y is equal to negative 60. And when I divide by -3, I get y is equal to 20. So now that I know what y is, let's plug this in to find x. So right here we know y is 20. So that means x is going to be 20 plus 30. So that means x is going to equal to 50. So that means that, let's see, what does that mean? Y is 20, so 5 times 20 is 100. 2 times 50 is 100. That makes sense. Everything, those are my alternate interior angles. We also know from here to here, that's 100 plus 30, which is 130. And if this angle right here was, what does that need to be? 30, 20, right? Okay, so you know that well, I guess we are done. We actually have all the angles we need. We need x. We've got to find x and y. So x is going to be 50 and y is equal to 20. So I could use those values and plug them back in, but they're not asking me to do that, so I don't have to. Next question says, the lengths of the sides of a triangle are this. So now we're talking about the sides of a triangle, okay? Find the values that make the triangle isosceles. So if I were finding the sides that make that isosceles, what I would need to do, let's say, here's 3t, here's 5t minus 12, and here's t plus 20. So in order to find the lengths that would make this isosceles, you would have to plug in each side equal to each other. So for example, you would either go, I would either say this side's equal to this side. So I would go 3t equals 5t minus 12. Or I would say this side is equal to this side. And I would then say 5t minus 12 is equal to t plus 20, okay? Or I would say this side is equal to this side. So then on the other hand, I could say that 3t equals t plus 20. So for me to find the values that would make this triangle isosceles, I would have to try all the different combinations that would make that work. So let's just start off. We got to subtract t, and I get 2t equals 20. T equals 10. So t could equal 10. So see, find the values of t. So far, we know t could be 10. Subtract 3t, I get 2t equals, move the 12 over, 12. T equals 6. Okay, so t could equal 6. Let's see here. Solve for t, subtract 1t, and I get 4t equals, I have to add 12. What's that, 32? So t is equal to 8. So I have t could equal 10, 6, or 8, and that would make my triangle isosceles. The next question says, use the given information to find the values of x. So basically with this problem here, we have two separate problems using the same picture. So the first one says that this is 14x plus 8, and that's angle 1. And angle 5 would be 17x minus 19. 1 and 5 are what we call corresponding angles. So you would say, and they're congruent. So we'd say 14x plus 8 equals 17x minus 19. Subtract 14, I get 3x. Add 19, what is that, 27? So therefore, x is equal to 9. We found x is 9. And then I need to plug my values back into my equation. So 14 times 9 is 126. And 126, so 126 plus 8 is 134. So we found angle 5 is 134, and so is angle 1. You guys, these are corresponding angles, and corresponding angles are congruent. So that means that angle 5 and angle 1 have to be the same angle, okay? The next question says, erase this, now I have to use the same picture, that angle 3 is 9x plus 2, so that's 9x plus 2, and angle 6 is 3x minus 2, 3x minus 2. So that means that those two angles are actually not congruent, but they are supplementary. So we can say that 9x plus 2 plus 3x minus 2 adds up to be 180 degrees. So that's what, 9, 10, 11, 12x equals 180. X is equal to 180 divided by 12. What is that? What is that? 180 divided by 12 is not an even number. Great. Let's see here. So 180 divided by 12. Let's figure out what that is, like 6. 12 times 6 is 2, 1. No, wait, that's not right. Hold on a second. 180 divided by 12. 1.5. That's not bad. No big deal. We can do that. Okay, so 1.5 makes 3 halves, or 1.5. Okay, I can just plug these values in to my equation. So 9 times 3 halves, add 2. So that's going to be 9, 10, 11, 12. That's going to be 27 halves plus 2. So what is that? 27 divided by 2 plus 2 is what? 15.5. So this part here is going to be 15.5, and then therefore this angle, which is number 3, is going to be 180 degrees minus 15.5. And that's going to be 180 minus 15.5, 164.5. So that's going to be 15.5, and that's going to be 164.5. Remember, they're supplementary, so they have to add up to be 180. So watch out for that. Okay, so we have all of these things. These are all those regular polygons. So we're going to be drawing some practice polygons, outline kind of thing. Find the measure of each exterior angle. So as soon as they tell me that, I'm going to draw my little fake polygon, right? This is like an outside. It could be any, it's like a generic polygon. If each exterior angle of a, find the measure of each exterior angle. So they want just one exterior angle. But it has 15 sides. So we just go 360 divided by 15. 360 divided by 15 is what, 24? So each one of these angles is 24. 24. Okay. If the measure of angle A is this, and B is this, and C is that, find the measure of each angle of a triangle. Oh, okay, well, those are just the angles. The angles add up to be 180. So we're going to say 3x plus 3 plus 2x, add 8, plus 2x plus 1 equals 180. So we got 3, 4, 5, 6, 7. So we've got 7x, 3, and 8 is 11, and 1 is 12. So 7x plus 12 is equal to 180. So we have 180, subtract 12, and that makes 168. So 7x is equal to 168. Excuse me, divide by 7, and I get, hold on, 168 divided by 7 and that's 24. So x is 24 again. So we got x. So that's not the answer, though, because they want the measure of each angle. So to find angle A, so we're going to say the measure of angle A is going to equal 24 times 3, add 3. So that's what, 72, 73, 74, 75. So that's 75 degrees. So A is 75. B is 24 times 2, which is 48, and 48 plus 8 is 56. So angle B is going to be 56 degrees. And then the measure of angle C is 2 times 24, again, 48 plus 1, which is the measure of angle C, which is 49 degrees. So I would just make sure, like just double check that 75 plus 56 plus 49 do add up to be 180, and they do. Because when you're doing these problems, you want to make sure that the angles of your triangle add up to be 180, but at the same time, you want to make sure that you didn't make a mistake, and you can double check it that way. Number 3 says, how many sides does a regular polygon have if the interior angle is 170? Okay, so again, couple ways to do this, right? There's my generic polygon. Interior angle is 170, okay? Which means my exterior angle is 10. All right, which means it's so simple that I just go 360 degrees divided by 10, and I get 36 sides. All right, and that I think that that's the best way to do this. Just a note, though, that each interior angle is 170. There's a formula that you can use, right? The interior angle formula, which is for one interior angle, it's 180 times n minus 2 over n. That's one angle. And therefore, you'd set it equal to 170. So once you did that, you would cross multiply, right? And you would distribute. Okay, we're going to get 180 n minus 360 is equal to 170 n. Subtract 170 n, I get 10 n equals 360. N equals 36 again. So I'm just saying that's an option for you. 2 different ways to do this, and whatever makes it easier for you, okay? All right, thirsty. How many sides does a regular polygon have if the sum of the interior angles is 9,180? So the sum, 9180, remember our formula, is 180 times n minus 2. So I'm going to take 9,180, and I'm going to divide that by 180, and I get 51. So 51 is equal to n minus 2. Add 2 to both sides, 51, 52, 53. So I have n equals 53 sides. How many sides does a regular polygon have if each exterior angle is 12? There's my polygon. There's my outside, 12. That means that my interior, right? My interior is going to be 180 minus 12, which is 168. But they didn't ask for the interior angle. What they want to know? How many sides? So all I have to do is take 360 and divide it by 12, right? 360 divided by 12, and that's just 3 times, that is 30. 30 sides. Okay? What is the measure of each exterior angle? Okay, so this is the exterior angle. I mean, I'm shocked to see we only have one of these, but remember, that outside angle is equal to the sum of the 2 remote interior angles. That's your formula. So you're going to go 6x is equal to x plus 17 plus 3x plus 1. So that's 4x plus 18 is equal to 6x. Subtract 4x. I get 2x equals 18. I get x equals 9. But that's not what they're asking. They're okay, like, yes, we found x equals 9. Check. But you have to plug these values in. So the first question is going to be in here. And you're going to say, well, what's 9 add 17? That's 26, right? 26 is here. So angle B, so the measure of angle B is equal to 26 degrees. 9 times 3 is 27, plus 1 is 28. So the measure of angle A is equal to 28 degrees. And 6 times 9 is 54. And so that this angle here, which you can't say angle C, because that could be this angle here, but you can say that this angle here, which is AC nothing, just this angle right here, what is the measure of each exterior angle? Oh, whoops. That's a different question, isn't it? Okay, hold on. Let me finish this problem. Find the measure of angle A and B. And just to double check, 9 times x is just 54. These do add up to be 54, which is what we want. Okay, so 17 and 18 I flip-flopped. Okay, I just saw the picture and I was like, okay, there it is. To do problem 17, I'm going to do that down here. It says, find the measure of each exterior angle of a nonagon. 9 sides. So we're doing this, right? Generic polygon outside, right? I'm going to figure this out. A nonagon, 360 divided by 9. That's easy. 40 degrees. So we got 40 degrees. Okay, done. The sum of the measures of the exterior angles of any convex polygon is always 180 degrees. The sum of the measures of the acute angles of a right triangle are 90. Okay. Or they're complementary. The sum of the measures of the interior angles with n sides, the sum is going to be 180 times n minus 2. One interior angle, okay, this is the sum of the interior angles. The sum is that formula. 1 is that formula divided by n, being n sides. On the day of the quest, all of these homework assignments are going to be due. Oh, and I forgot to put on here, there should be a really fun angle diagram sheet, which is also due. Okay, so all of this stuff is done. Depending if you did all the assignments or if you just did the updated version, those are all due on the day of the quest. So wishing you the best on your test. Be the best that you can be, as always. Thank you for watching. If this helped you in any way, I'd love to hear from you. Let me know. All right, thank you so much.